Hi, I'm Jefferson Murwa, and we welcome you to the ISSF Skipper Workshops for purseeiners. Today we're going to be talking about best practices and ways to reduce bycatch in tuna purseeiners. I'll be joined by Dr. Martin Hall and David Itano. At the moment there is some criticism of fad fishing, and there's been some campaigns which are trying to limit or prohibit the use of fads in tuna purseine fishing. They think that fishing with free school or pole line is more sustainable. We know that purseine fishing with fads produces a small percentage of bycatch, approximately 2%. But even so, we have to do our best to reduce that and have the most sustainable fishery possible. One way to increase the sustainability of the fishery is, for example, trying to obtain certification for that fishery. This certification, what it does, it audits a fishery and it makes sure that it's up to certain standards where bycatch is low and all the regulations are complied with. And it's a way forward to increase the sustainability of fisheries, which is not only in tuna fisheries these days, but across all fisheries in the world. ISSF, which was founded in 2009, is one of a kind in the tuna industry or the tuna fishery, in terms of uniting for the first time industry, renowned scientists, and environmental groups such as WWF. The members of ISSF move more than 75% of all the volume of canned tuna in the world, and it's the concerns of industry, scientists, and conservation groups to improve the standards and the sustainability of the fishery that created this foundation. ISSF objective is to increase the sustainability of the tuna stocks and the ecosystem that surrounds it, and utilizing the best available science to try to study and research the best options for the fishery. ISSF has shown a commitment to improve the rules and management of the different commissions, and also is trying to promote that tuna fisheries reach the standards required for certification without conditions. One of the initiatives that ISSF is using at the moment is the Proactive Vessel Register. This is essentially a database where buyers and markets can go and check which boats are doing the best available practices. In this database, boats subscribe and they show what commitments they're taking and doing at the moment, and this can prize those boats that are doing the best fishing in the tuna fishery. If you go and access the PVR database, you'll see the name of the boat, where it's been flagged, if it's got a unique identifying number, if it's doing and is respecting all the regulations from the commission where it's fishing, and also it's doing other kinds of practices like having observers on board, retaining tuna, and for the purpose of this workshop is also see if the skippers that are in charge of those boats have received education or have participated in bycatch reduction workshops as the one we are showing today. Another way to increase transparency is to have observers on board. Observers can record information and verify that the practices that are being done are correct and there's little bycatch. And one thing that is happening these days in the last few years is that we're moving from person observers to electronic observers in some fisheries. And these electronic monitoring systems have been tested and funded by ISSF campaigns, and we're seeing that maybe in the future there'll be more widespread. Electronic monitoring systems can show exactly what's happened during the fishing operation, where the boat is located, and much more information that is useful to scientists. In this next slide, we're showing the ISSF database for all the Tuna Commission regulations. This is an excellent source if you want to learn about different regulations in your ocean. You can check online and you'll have all the information organized and readily available for you. The purpose of the ISSF skipper workshops is to interact with fishers and try to get their feedback, because we know fishermen are the real experts in fishing technology and they have thousands of hours of experience at sea. This is something that most scientists don't have at hand, and the purpose of doing these workshops is to learn from skippers and try to interact to find best available practices. So the way the skipper workshops done in person work is scientists propose ideas to reduce bycatch and things they have tested before and work. Skippers learn about the things that have worked and give feedback on the experiments that will be done in the future to test bycatch mitigation measures. This is a very practical way of doing things because it gives skippers the chance to voice their concerns and give us their feedback on what they think, and also for scientists to not waste valuable time and resources trying things that you've told us might not work at sea. One thing with the tuna fisheries is they're global. They spread all around the world. All the equatorial line of the world is an area of fishing for tuna. And this is why the ISSF skipper workshops have been targeted to go to the principal ports, tuna ports, and the most important tuna fleets in the world. And since 2009, we've been doing workshops all around the world. We've had more than 600 skippers from fleets that come from Asia, Africa, Europe, North America, and South America. It's very important for us to learn the differences between the different fleets. One thing that's important in these workshops is that we are able to characterize the fleets, what kinds of boats they use, what kind of practices, what's possible to try and test in their boats and what not. This feedback is very important for these workshops, and also when we come up with solutions, we want to make them tailor-suited to each fleet, so they're really going to work in your fishery. These are examples of different boats. We can see Spanish, Asian, Indonesian, American boats. There are many different types of boats, and we want to learn about the equipment that each one uses.
My name is Martin Hall. I've been in charge of the bycatch programs at the Inter-American Tropical Tuna Commission for about 30 years now, and we've been dealing with bycatches of different types, dolphins, sea turtles, and other species in different fisheries. So we are dedicated to this issue, and we have developed a relatively long experience, and we have learned quite a few lessons, which is what we want to share with you. And one of those lessons is, which is at the core of these workshops, is the fact that we have a lot to learn from a fishing community that is committed to help us solve the problems, and we go to them in a very direct way. And we have developed through the years a system based on the acquisition of data through observer programs, a scientific analysis of those data to identify the problems, and then a continuous interaction with the fishermen to find the solutions to those problems. And that's the process that we have used with dolphins, with sea turtles, and with all the other species. And this is a process that we utilize as a normal way to develop a strategy to address a problem. Fishing, like all other human productive activities, has impacts on the ecosystem because of the harvest and because of other species which are affected by fishing practices. The objective of a modern approach to fisheries is sustainable fisheries where the impacts on the ecosystem are minimized. One of those impacts is the one called bycatch, and I can describe the concept based on this slide that you're observing now. Imagine that everything that is retained in the net is called captures, a name that we invent to describe the whole physical content of a per seine. Of that fraction, there are some animals that we can release alive and we expect to survive. We call that the release. An example would be dolphins in the tuna fishery, where we had a major success in reducing the bycatch by 99% while maintaining a fishery which is highly productive. So that portion goes back to the ecosystem unharmed. Another portion is retained by the boat because it has economic value. We call that the catch. And it is an economic term. It's just defined by the economics of the situation and includes all the species that the fishermen retain and utilize. The third concept, which is bycatch, is what is discarded dead. Basically, what is discarded dead is something that is no gain for the fishers and no gain for the ecosystem. It's in a way, in other words, the waste of the fishery. So the objective of a fishery is a sustainable catch, where all the species are well managed, and then a minimum bycatch, where the impact on the ecosystem is the minimum to produce the catches. And these are the basic concepts. So the idea of this program is to produce sustainable tuna fisheries in the per seine gear that we are working on, and at the same time minimize the bycatches, the discarded dead of other species. And of those bycatches, some of them are species of conservation significance because they are long-lived individuals with a small number of offspring and long reproductive cycles and so on. So those are special problems from the point of view of conservation. Others are species which are highly productive and perhaps don't have problems of that sort. So we deal with these different issues in different ways. So conservation issues require that we release those individuals as much as we can, whereas some of the others can be utilized. We're going to show you a couple of examples of the different practices.
There's also a certain group of characteristic species that appear when we talk about bycatch in tuna fisheries, in per seine fisheries, and these comprise turtles, bony fish, whale sharks, manta rays, small tuna, and sharks. Perhaps the most important at the moment, the one we're focusing most on, is sharks, because their populations are declining and these species are in danger in some areas, and we want to try to maximize the survival of these sharks.
What we want to do is to develop what I call an engineering approach. Simply decompose the problem into stages and see how can we deal with it. And in this case, is a series of stages, a sequential approach. So if we want to avoid incidental mortality of something that we don't want to kill, first of all, can I avoid capturing that individual? So if I don't encircle the individual, there is no danger of killing it. So first thing is avoid capturing it. If I fail to do that, the individual is in the net. Can I release it from the net now? In the case of the dolphins in the tuna fishery, there is a maneuver invented by the fishermen that allows the dolphins to be flushed out of the net while retaining the tuna. So that happens, and it's a solution to the problem. If you fail to release them that way, you bring them to the deck of the boat, and then you have to develop techniques to release the animals, which are based in science, to try to maximize the survival. And then if you fail and the individuals are dead on the deck, there are some species that you cannot retain because of legal issues or regulations, but there are other species that you can retain, and in the past, some of them have not been retained. So the last issue is utilization. If something is dead on the deck and you utilize it, you turn a bycatch into a catch. So how can we do with these species? Well, many of them had no markets. In some cases, the storage in the perceiners, which is a brine solution used for tuna, was not adequate to storing these other species. But there were some species which are very valued by the public, such as mahi-mahi, wahus, and other species. And what happened in recent years was a development of techniques of capturing these individuals of high value from the net, developments on the boats utilizing wells for these other species without the brine solution, and then the development of a secondary industry, which is, for instance, doing very well in Ecuador, where there are plants which are now receiving all these species that were discarded before, utilizing them into products. And in this slide, it shows a variety of the products that are being used. They are produced, they are packaged, and they are sold, and they are exported. So there's a big source of funds for a country. They're a source of exports. And it was a product that was dead and discarded before. So it went from no value to being a significant export product for a country. So these animals can be utilized because they are very highly productive. And only a few species fall in this category, and they have a very good market. So mahi-mahis and wahos are good examples of this. We do not utilize the shark species, which are the ones which are problematic, or species which are conservation issues. We are not proposing that, but there are many that can be utilized. So some of these species used to be discarded in an 80% or more. Now the discards are of the order of 10 or 15%. So this has been turning waste into a product, and at the same time filling the boats with something that helps reduce excess capacity in the fleets. The research that is necessary for some of these release techniques is very important, and it's something that we have made very, very strong progress in recent years. And you have individuals of different species that arrive at the deck. And the question is, you want to put them back in the water in a way that you maximize the chances of survival of these individuals. So the crews have developed their own techniques, but those techniques were based on practical considerations and not necessarily knowledge about the individuals. In some cases, they were also unsafe for the crews develop and utilizing these techniques. We need to develop methods which are based on the best veterinary science and biology, which are good to maximize the survival of the individual release, at the same time being very careful that the safety of the crews is not put in danger in any moment. So that's one of the issues, to do successful release from the deck, which is one of the maneuvers that we need to do. So for instance, for sharks, you can see some examples here which are not exactly healthy for the crew doing that type of movement. Another example, which is fairly common, is trying to lift a large shark using some of the winches in the boat from the tail. And a heavy animal lifted by the tail has an anatomy that is not prepared for that type of pressure. You can imagine that a shark is never hanging from its tail in a normal situation in the ocean. So a movement like that, even though it's trying to release a shark alive, it may cause exactly what they didn't mean to cause, and just kill the animal in the process of trying to release it. So we need to develop better techniques to do that. So one of the issues is to improve the practices used to release animals from the deck and to disseminate that information to maximize survival. So sharks which are small can be safely handled utilizing 2 points, just putting one hand in the tail and one in one of the lateral fins, or there are other techniques which have been developed by the crews, and in general it's not a huge challenge. The larger animals are more of a problem. But the techniques have to be safe for the crews so that the animals cannot turn around and bite the person releasing them. The other sharks they need to be released from the deck. And in recent years, there have been experiments, many of them funded by ISSF, where they have tested different alternatives. And for instance, a small device used to carry very safely, and for the crew and for the shark, a relatively large shark out of the deck. It's a very simple system, and in other cases, they have to adapt the release method to the vessel type and to the machinery and equipment on the deck. But ideas like this are being tested now for sharks, manta rays, and other species, and I'll show you some other examples. So the turtle releases are another issue of significance. The number of turtles caught in the Seine fishery is extremely low, and we're very fortunate with that. There are a few which are entangled in the net, and a few which are caught inside they're entangled or caught inside the Seine. Most of those, practically all of them, are alive when they are encountered. So good release techniques result in survival. And at the present time, the mortality of sea turtles in the whole Eastern Pacific region, for instance, is about less than a couple of dozen. And of the turtle, which is the most numerous, most abundant, and it's a turtle that is increasing in numbers. So we're extremely lucky that the turtles, which are 2 or 3 species, where are deeply endangered, those are not attracted to fats in general, so they are not caught by the Seiners. But they do have problems from other fisheries and from other factors. So the turtles must be handled by 2 positions, and it's illustrated in the left side of this slide. And what should be avoided is turning the animals upside down and leaving them on the deck, heat on them for a long time, or lifting them from the flippers, because these animals don't have the joints prepared to the type of stress that is caused by somebody lifting them that way. So they should be used with 2 hands, 2 points, make for a very good release, and they are luckily infrequent issues. So practically no problems from this fishery on the sea turtles, from the Seine fisheries, but the several species of sea turtles are deeply endangered because of impacts of different types. Another group of species of interest are the manta rays. The number of manta rays captured is not large, but it's very difficult to say what is large and small in the absence of total population data. We don't know what is the size of the populations of manta rays, but we do know that they're very vulnerable because of their life cycles, and I will say a few things about that in a minute. Manta rays are very large, and the efforts to release them are complex and risky for the crews and for the animals. So we suggest a couple of things, and at least we have identified practices that need to be eliminated. So the traditional method of release are these 2 illustrated here. And they are practical given the conditions of the boats, but we believe that both are extremely harmful, if not deadly, for the animals. So we are quite convinced that these 2 methods should be eliminated. So what we've done from here on is go to skippers and crews and say, if you want to release these individuals and you don't do it this way, which are the options that we have? And what is happening right now, which is one of the interesting things about this program, in different oceans, different people are testing different ways to release the manta rays alive. And so I will show you a few examples, but there are more things in development, and we receive ideas from fishing skippers, sometimes even from the sea, saying we are building this type of prototype to release the animals. One of the very rewarding things of this type of activity is that when you go to the fishing community and you bring a problem and you ask for the cooperation to find a solution, you really find the cooperation and you find the interest and the curiosity. They understand what the problems are, and then they become a force in finding a solution to the problem. So these are the methods that we believe should be eliminated, and then we show you a couple of reasons. First of all, the manta rays, like sharks and other species, are very vulnerable because of their life cycle. They have sexual maturity, which is 3 or 6 years. They have only one or a few offspring every 1 to 3 years, a very long gestation period. So even a mortality of a few thousand individuals may be significant. And in this case, we don't know how localized the populations of manta rays are. So to assess the impact of the mortality is very difficult. So instead of spending a lot of time trying to assess that impact, the objective is fishermen don't want to keep the manta rays. Then what we need to do is give them a good way to facilitate the release and measure the survival. In some cases, the tuna and the other components of the catch are dumped on the deck of the boat on some structures called hoppers. Those hoppers are very useful to separate by catch or to identify where the problems are. And nets or other things can be put on top of those hoppers. There are ideas to put hoppers which are tilted so that some of the large animals can be moved aside. And one concept that is important is lifting animals like large sharks or manta rays is not a great idea for the survival of the animal. So we need to look for formulas where either they can be released without lifting or where the lifting is more benign than the current systems. So the diagram that you have now shows an example where one of those structures includes a tilted plane that facilitates the release of the sharks through an opening on the side of the boat. So we are asking the modification of the side of the boat to include an opening, some type of a door, sliding door, or some other type that makes it easy to slide an individual back into the water without lifting them over the side of the boat, which is a more practical way. So this case goes from the brailer into a plane and back into the water. So we have, since we started talking about this, some of the vessels have started developing different styles of these ramps doors. And we hope to have more improvement in this along this line. And it's something very important. It requires that they also consider the safety of the crew by putting openings, additional openings on the deck. But this is an area of lot of progress and promise. So to illustrate the magnitude of the problem, here is an image of one of the largest manta rays that has been observed. And this is that, don't believe that this is the norm. The norm are probably under 2 meters in width. This is one of the giants that can be caught in a Seine. So these individuals present a major problem for the crews and for the animals, of course. And they are very valuable from the point of view of conservation because they are usually highly reproductive individuals and so on. And some of the rare species may be in this category. So this is a kind of challenge that is necessary. And we need techniques that work for individuals like this. And then a side door with sliding the individual laterally, which was the advice from an expert on manta rays, could result in a safe release. And this all these ideas should be accompanied by scientific experiment showing that after the release, there is survival. We don't want to put them in the water to feel good. We want to put them in the water to ensure their survival. So the idea is make sure that what we're doing is effective for the animals. So here you have a couple of examples of ideas. And they are smaller sizes than what we'd like to see, but they are the beginnings of this process of adding ramps and openings on the side of the boat to facilitate the release of large individuals. You have an example with this video of the difficulties that are presented when the attempt to release an individual are done manually and without a really strategy for release. So in this case, you have 5 individuals trying to move a manta ray out over the side of the boat, and it is a relatively clumsy maneuver. It takes a lot of time. It's not. It doesn't look like something fluid that you want to imitate. So this is an example of the degree of difficulty of the release and the fact that we need more effective ways to do this. Okay, in the video that you are seeing now, you can see an animal which is brought by a brailer to the deck of the boat, and you see the crew approaching the animals. In many cases, these species are in the upper part of what is put on the deck, and then the crew uses, in this case, a type of netting to capture the animal and to release it over the side. They are testing different types of netting, and they are more effective in moving the animals from the point of view of survival. This is a lot less harmful than the previous technique, and the question is how effective, how practical, how quick is the maneuver for the fishermen compared to alternatives. So here you have it, and there it goes. And this maneuver is a lot more desirable from the point of view of the individuals than the traditional ones. For manta rays and large sharks, probably one of the most interesting concepts in view of many of the skippers is the use of what is called cargo nets. They are very large mesh nets, and the idea is that the catch is dumped on top of this large mesh net, the tuna go through the meshes, and the large individuals kept retained there, and they can be released using these nets. So this is an example of how the cargo net could work for the release of a manta ray, and these are some of the techniques that are being explored. This is something that many of the fishermen find very effective, and it's simple, it's very low cost, and relatively quick. So it's very desirable from the point of view of survival of manta rays, safety of the crew, etc.
Hello, I'm David Itano. I'm a tuna researcher. Been working with tuna research and research for applied management since the 80s. ISSF has been working with different organizations to try and develop best practices for the release of whale sharks. And in this regard, the skippers' workshops have been extremely important because it's the experience of the captains on the boat who have to deal with these significant issue, and quickly and efficiently, as much as possible. And it's their experience that we rely on in many cases. This diagram on the left shows one method of releasing a whale shark, which is called rolling the shark out of the net. This is a fairly passive way to pass a rope or a cable beneath the net and the animal attached to the cork line, and as it's pulled, it will submerge the cork line, and then through tightening and slacking of various parts of the net, roll it out. Now, this can be greatly assisted by, in the bottom left of the screen that you see, these are purpose-built weights connected by a heavy line or chain that can be lowered onto the cork line to help to sink the corks below the head of the animal. We know from talking to fishermen, it depends on various aspects of the conditions of the encirclement, and that would depend on the size of the animal, whether it's oriented to the bow or the stern, how much catches in the net, and also the environmental conditions. On the right side, we have some warnings to not do. Obviously, it's not good to try and lift the animal by the tail or lift the animal out of the water at all. And we discourage connecting to the tail and towing the animals sideways. So these best practices are still in development with industry and working on these issues to minimize impacts to whale sharks.
Okay, this slide is showing that when we have FADs, it doesn't matter how much tuna is under the FAD, the amount of bycatch is always going to be more or less the same. So if we have a FAD with 300 tons of tuna or a FAD that has 10 tons of tuna, the amount of bycatch species associated with that FAD are going to be very similar. And in this next slide, what we can see is a study that was conducted in the different oceans of the world, and it compared the sets that were done where 10 tons of tuna or less were caught, and the sets that had more than 10 tons of tuna. And what we can see in these examples, for example, if I point at the Western and Central Pacific Ocean, we can see that 27% of all the sets resulted in less than 10 tons of tuna. So 1/3 or 1/4 rather of the sets produce 1/4 of the bycatch. We were saying that all FADs have more or less the same bycatch species amount. When we look at the amount of tuna that is provided at the end of the year, only 3% of the total catch of tuna came from those 27% sets. So what this study showed is that those small sets produce a very small amount of tuna caught at the end of the year, but result in a larger amount of bycatch. So it would be advisable to avoid those small sets and target larger sets because they're more profitable for the fishermen. In this next set, we move on to the issue of FAD entanglement. And this slide shows research that was done in the Indian Ocean by fisheries scientists. And what these scientists did is they went and dived. They sent divers in the water next to the FADs, and they checked how many sharks were entangled in those FADs, if any. And they found that in 1/3 of the FADs, there was one shark entangled. And also, what they did is they put tags on live sharks, and in the graphic in the center of the screen, it shows that those sharks would move naturally for several days, 0 to 20 days there, and after a certain amount of time, they wouldn't move anymore, and after a couple of days, the tag would sink to the bottom of the sea. And we think that what was happening there is that the sharks would moving freely around the FAD. One day they become entangled, and they get stuck there. They die. Some other fish around might eat or nibble on them, and the tag falls down to the bottom of the sea. Here we're going to show some information on how to solve this problem of FAD entanglement. We're going to talk about non-entangling FADs, and next we'll move on to other measures to reduce shark bycatch. ISSF has produced a best practice guide which you can download from the ISSF website, which shows which are the principles by which FADs should be constructed and designed. And the principal issue with non-entangling fads is that we promote the use of zero netting in the construction of fads. If you don't have netting in the fads, there's no entanglement. So one of the things is avoiding the use of netting. Other thing is to have smaller rafts of the fad, which prevent turtles climbing onto the fad to rest. And the third issue would be try to construct your fads with materials which are biodegradable. This is the guides that ISSF is proposing, and we're seeing some fleets that are moving towards that direction. There are also regulations that are coming from the tuna commissions, like the ones in this slide, and we see that in the future it's quite probable that most commissions will ask for all fads to be non-entangling. So here we're going to show you some examples of designs that other fishers have been using in the last few years, and also give you recommendations as to how those fads can be used. One thing with, for example, the anchored fads is that these payaos or anchored fads are built without any netting. They're still attracting tuna and they're still efficient, but these anchored fads are completely non-entangling because they use other materials than net to construct their structures. Up to now, there's been a move which has gone from entangling fads towards non-entangling fads, and there's been a transition period where fleets have been using alternative designs in which small netting or tied-up netting has been used to construct these fads. When ISSF proposed their guidelines for non-entangling fads, it contemplated this period of time for transition to let the skippers adapt from fads which have been always constructed with netting to move to something which doesn't have it, and these have been kind of an intermediate step, which are less entangling, but now we're trying to move to fads with no net at all. And here are some examples of some fads that have been used by different fleets, and they have been used successfully in commercial fishing in the last 2 years or so. This slide here shows one of the most used transition fads up to date, which uses small netting on the top of the raft and sausage or chorizo tied netting under the raft structure. This has been highly successful in the Indian and Atlantic Ocean, but the trouble with these transition fads is that if the tied netting becomes undone, or the netting starts to break down, then the gaps in the mesh become bigger and they're more likely to entangle. So that's why we recommend using no netting. In this next slide, you see a similar version of a fad to the previous one, but this one is completely non-entangling because it's using rope underneath instead of netting and a cloth or canvas on the top of the raft. In this way, we achieve a non-entangling fad, and the structure and design of the fad is not substantially different in terms of drift and behavior in the water. This is a characteristic fad that's been used generally in many oceans, and we'll see that it has a lot of netting, hanging underneath, usually recycled per Seine netting, and also netting on the top. And what this causes, or is more prone to, is to cause entanglement of sharks and turtles, as we've talked before. This other example is a non-entangling version of the previous one. So we still have a canvas underneath that acts as a sail to move the fad with the currents, and we have taken away the netting on the top and the bottom. The structure is simpler and also probably easier to make and even cheaper. Here's an example of a biodegradable fad prototype that has been tested in the Indian Ocean, and it was constructed with materials that were strong enough to last in the water for the expected lifetime of a fad, but after that lifetime they would start to degrade. So scientists at the moment are experimenting and trying to identify which are these best biodegradable materials in terms of price, strength, durability, and we're trying to do studies to identify those materials so that the next step after doing non-entangling fads is doing biodegradable non-entangling fads.
Okay, through research cruises we've conducted, ISSF has sponsored. These research cruises basically put scientists out to sea with fishermen, which is very important so that they're able to interact on a daily basis on a fully commercially rigged vessel in real situations to try and minimize impacts to non-target species. What we've learned from looking at the shark situation, this is oceanic sharks, silky and oceanic white-tip sharks, is that it's certainly better to avoid them completely or to release them from the net to maximize survival, because once they've been loaded on board the boat, they may have already suffered trauma that could be fatal. One concept of releasing sharks from the net, and this is before they're impacted at all, the net is still very large, is to just let the fad drift toward the back of the net. The idea being that perhaps through just a natural drifting of the boat away from the net, the sharks might be congregated toward the back end of the net. We observed this in a research cruise, ISSF-funded research cruise, where indeed sharks, and this is mostly silky sharks, and bycatch were collected toward this bend in the net that formed late in the net hauling process. We kept seeing sharks in this area of the net. If we put a panel in there that we could open and close at will, perhaps this would be a way to release the sharks. And the bottom is just a net diagram showing you in the big arrow where eventually that net panel went in. Here you can see the vessel upon which these experiments were made. We first observed that if we were inside the net at the surface, the natural movement of the boat to starboard during the net hauling process would congregate ourselves at the end of this corner of the net. And in the right panel you can see sets where indeed silky sharks were congregated there, far away from where the tuna were concentrated. The process of opening the net is quite simple. The observations are made from a workboat at the apex of the bend in the net. If there are sharks aggregated there, then we'd signal the boat to stop rolling the net. We'd hook up the workboat to one end of a line, detach the other end of the line, and this line ran through rings connected to the panel. So just by pulling that, it would cause an opening of about 25 by 35 feet to form in the net. The sharks were often quite right there, very close to the area, but unfortunately they tended to want to remain in the net. So additional experiments are planned to try and either repel them out to that area, out of the net, or attract them out through chumming or some other means. Here is an example of what's happening. Anything in the surface of the net, just through the action of the boat being pulled to starboard and the bow thruster moving to starboard, tends to aggregate whatever's in the surface at this apex of the net, which is a dynamic bend as this net is being retrieved by the power block. And between the two red dots you see on the screen, that's where we placed the escape panel. The thing is that in subsequent cruises on other vessels and in other oceans, we didn't always see the formation of this bend, this phenomenon, and this aggregation of sharks and bycatch separate from the tuna. For example, here's another vessel in the same stage of net retrieval, but the net's far larger. So basically, this is part of the process of ISSF cruises to examine ways to mitigate bycatch, but not just by applying something we see in one area to another, but by looking at all different areas and different fleets to see what might be most effective. But experiments will continue with this concept because we certainly know that if we can avoid or release them from the net, that's their best chance of survival. Another experiment that we hope to carry out on future cruises is to take the back down procedure, which was used very successfully to release porpoise in the Eastern Pacific in sets where large tuna are aggregated to porpoise schools, where the net is retrieved to a certain stage, locked down, and then this purse seine boat is backed up, and then causing a channel to form and one end of the net to submerge. And you're literally pulling the net sort of out from underneath the porpoise school. We're wondering if this concept can be applied to fad fishing. So here you see in the upper left panel a set being made, and in the middle a fad connected to a power towboat. The idea is the towboat would keep the fad in the middle of the net, and then during the back down procedure, which is the right top panel, number 3, the towboat would slowly guide the fad out of the back down channel and out of the net. At that end of the channel, there would be observers and video cameras to document what went out and what did not. This obviously is just an experimental proposal that we hope to develop. Another aspect of the research cruises that we conducted was to look at the natural behavior of tuna in the net. And this is something that had never really been observed before, and this is a great opportunity, and again, a wonderful opportunity that these research cruises afford, because you can't just simulate this sort of thing on a research vessel. On these research cruises, we're able to go into the net with video cameras and our eyes to actually see what was going on. And this is something that even the fishermen weren't aware of what was happening in the net with the tuna, the bycatch, etc. Are they mixing completely? Are they maintaining some separation? And we were extremely interested to see that indeed the tuna segregated very well by size and species. The big tunas, yellowfin and larger bigeye, and the deep part of the net. Then some mix of middle-sized yellowfin and bigeye above them, and then skipjack, usually more shallow, but kind of changing places in the net back and forth. And of course, when there's a large predator, everything kind of tended to mix up and break loose. But we even observed predation of large tunas on the small tunas in the net, which hadn't been done before. Something that we were highly intrigued to see was some separation of big eye, small big eye tuna from the small yellowfin in some areas. And this was intriguing because no one ever thought that this was possibly occurring in the net. And this might offer hope that we can find something that we can use to exclude those big eye, which are of management concern right now, from the set while retaining the yellowfin, which are still a target, very much a target species. Okay, in this video, we can see some of the natural behaviors of both the bycatch and the tuna we saw and observed inside the net. This is the bend of the net I was speaking to. When the power block's been stopped, you can see shark, mahi-mahi, some other bycatch species up shallow and collected there, far away from the tuna, which are down below, deep in the net. At this point, the net's about 150 feet deep because much of it has already been retrieved. Here's monospecific schools of, this is all skipjack driving together. This is a mixed school where we had large yellowfin down at the bottom, as you see here. And far above them were the skipjack and the smaller yellowfin and big eye tuna. The water clarities are quite impressive in the Western Pacific, as you can see. That was another issue with the trials with the escape panel, was during the first part of the trip when we observed a lot of these separations. The water seemed to be a lot more clear. This is toward the latter part of the net retrieval, when the large yellowfin are coming to the surface and acting a bit agitated. This is probably at a time when it's no longer possible to separate species and to selectively release because of the mixing going on.
In addition to bycatch species that are not tuna, we're also working on trying to minimize the impact of fishing on small or juvenile tuna. And here we present some of that research. In this slide, we can see some of the experiments we're doing with acoustic discrimination. We've tested in our ISSF campaigns in the Western Pacific some novel equipment where we have 3 echo sounders at 38, 120, and 200 kilohertz frequencies, which zoom on the fish under a FAD at the same time. We know that the response that the echo sounder receives from the tuna schools is based primarily on the air bladder or swim bladder that fishes have in their bodies, and skipjack have a very small swim bladder, whereas big eye and yellowfin have a swim bladder. This swim bladder is used to move up and down the water column. And when there's a big air bladder, you get a bigger signal because the difference between air and water density is greater. So what we've done is try to create screens when we look with the echo sounder down into the fish that are under the FAD, and see if with these screens we can identify which species are forming those schools. So for example, in this slide we can see that skipjack, which has no swim bladder, there's a strong difference in the image that we receive when inspected with 38 kilohertz frequency and when inspected with a stronger signal of 120 or 200. And we can see that with these images we can know if there are a lot of skipjack or not under that FAD. Whereas when we look at big eye and yellowfin, which have a larger swim bladder, when we zoom in with the three frequencies at the same time, we see that the difference is not so great between strong signal and weak signal. So we're still working towards improving how we can know with the acoustics of the boat which species are in a FAD and be more selective in that way. One of the things that we did also in our last research cruise was have a FAD and attach several brands of ecosounder buoys and examine also with the ecosounder of the boat what kind of images or information we were getting back from the different brands, and this helps to try to understand and calibrate better what's in the school underneath and what we receive and what the fishery is receiving when he's in the boat. We've tried to also tag those animals with electronic tags, the different species, and see how they move up and down in the water column, and try to translate that or put it at the same time with the images from the ecosounder and understand better what the images of the ecosounder are saying, which species they're really showing. So that's something that we're trying to further and advance in. In this slide, and just to summarize the basis of this workshop that you have just seen online, we like to say that it's important to see where the market is going and how there's consumer pressure to fish more sustainably. That's what people demand when they buy their products. There's an advantage for the fleets in being more sustainable. That open markets and is generally better for the business. We are trying to be more selective, and we propose these measures that you may apply in your boat. And the primary thing is if you can avoid catching it, that's the most efficient to reduce bycatch. Then we see when they are in the net, how can we get them out of there? If they've gone on the boat, how can we release them from the deck? And if not, if it's possible to utilize those species, then that's another option. We strongly encourage everyone to put into practice the best release methods from deck, and throughout the future we'll continue with our research. We'll try to give you feedback on what we've been doing and show you the new results and propose measures that we arrive at. And we'd really like to thank fishers and everyone involved in the industry, because we think that collaboration between fishers and scientists and the industry is essential for a sustainable fishery. In this last slide, we'll leave you our website of the ISSF, where you'll find lots of information on bycatch and many other issues in the tuna fishery. We also leave the emails of the presenters. If you have anything that you would like to discuss with us or ideas to improve the measurements that we've proposed, we are very happy to listen from you, and we'd really like to thank you for your time and your attention.